Alrighty, welcome back. This is our last section that we are covering. Last lesson of the year. Yay! Permutations, combinations, 12.5. If you are taking a future probability class, you will run into these statements again. Definitely stay tuned for what this section brings. There is a lot of context involved in these problems, so like any probability problems, but this is probably the most of all of them that we've run into. All right, I'll read this fast. Used to determine, fundamental counting principle. Used to determine the number of ways that multiple independent events can occur. If there are m ways one event can occur, then and n ways that another independent event can occur, and p ways that another event can occur, then there are m times n times p ways that an event can occur. Okay, so basically we're just finding sample space. That's all we're doing. We've done that before, but we are starting to make it a little easier with this. How many different ways can you roll a six-sided die? 6. 1, 2, 3, 4, 5, 6. Flipping a coin. Heads or tails? 2 different ways. Answering true-false question. True or false? Would be 2. So how many possible outcomes are there? 6 times 2 times 2 is 24. Great. That's it. That's all we need to do. Choose a marble out of 10 marbles. 10 possibilities. There's 10 marbles. 6-sided dice. 6. Flipping a coin. 2. And multiple choice questions. 4 possible answers. A, B, C, D. 4. And that's it. So multiply those up. 480 possibilities. Sure. Okay. Why did we do this? 1, to show the easier way to find sample space. But 2, notice that we're going in order of how many different things there are and how many possibilities there are after the one event occurs. Right? And so that's going to play a part into permutations, which we're going to talk about. Permutation, an arrangement of objects in which order matters. Okay, that's the key part of permutations. This is where you're really finding out probability of, or at least different possible outcomes of things. So consider a number of permutations of the letters in the word July. How many different ways can you arrange all the letters in the word July? Let's just write out July, right? That's one way. Now, the way I'm going to count them is I'm just going to list as many possibilities that I can with J at the start. If I can do that, I can just multiply that out later, replacing J with a Y or something like that. I'll explain that a little later too. So you could have J, you could have U again right there, but you could have Y and L switched. That's about it with U there. Let's try L here. Well, you could have L-U-Y, or you could have L-Y-U. Well, and the last one would be J-Y-U-L or J-Y-L-U. Notice I just did U's, L's, Y's. That made my life a little easier. These are all the possibilities with J at the start. Well, now you can do the same set of stuff with Y at the start, U at the start, right? L at the start. So there's 1, 2, 3, 4, 5, 6 times 4 different letters, right? 1, 2, 3, 4. So you just have 24. Nice. Oh my gosh, that's a lot of counting. All right, let's try 2 letters, just 2. Well, you have J, U, J, L, J, Y. In the same fashion, you'd have U, J, U, L, U, Y. Okay, and you do that with the other 2, right? Same thing. 3, 1, 2, 3 times 4 letters, would be 12. Okay. What if these numbers get bigger? That's what a question I get asked sometimes, especially at the first section. What do we do? Well, fortunately, we have a formula. Yay! We can do it with a formula. In order to understand the formula, you got to know a couple different parts of it. P means permutation. N means number of things taken, or like the total, kind of, right? R is like the favorable amount, or I like to say the different ways. You'll see that a lot in problems. What are the different ways, right? They'll say that quite a bit. Okay. Exclamation point, that doesn't mean we're excited to have N as the front, as the top number, or the numerator. No, it's not that excited. No, that the exclamation point means factorial. What's factorial mean? Well, in the previous problem, we have 4 as our N. Okay, and what you're doing with 4 factorial is that it means 4 times 3 times 2 times 1. That's what that means. 4 possibilities times 3 possibilities times 2 possibilities times 1 possibility. That's what that's doing. And if we had, like we had in the other problem, n minus 2 factorial, you have 2 exclamation point, which really means 2 times 1. Okay, and what it does at the bottom, what the formula is doing is it's canceling out those different possibilities to eliminate that double counting. Okay, now you just have 4 times 3, which is 12, which is what we had that last question. So that's what the formula is doing. This gets you the permutations. Let's do a problem and see where the exclamation point is, because you're going to need to punch this in on a calculator. Now, not a fan of this problem. This will get you a ginormous number. You will not get these kinds of numbers all the time, but it's good to show, good to apply to other classes, and gosh, I wish it was going to be a different problem, but this is what we got to work with. 20 children are leaving honors geometry class. Oh my gosh. You guys are leaving. How many different ways can 18 out of the 20 children leave? Like I said, order matters for permutations. So you could have one kid leave first, another kid leave second, third, fourth, fifth, all the way through 18. Now, what if that kid at first, that left first, now left fifth? Right? And what if that kid that left fifth left second? And you go down this list of kids that leave in different orders all the way through 18. That's going to leave you with hundreds of thousands of different possibilities of how those kids could leave, right? And then you have 2 kids that may be included in this too. So that's where the 20 comes in. So you have so many different options of how this could shake out, right? In order to find that, we're not going to be able to count like we did up here. We're going to have to use our little formula. So we have a total number of 20 kids, 20 factorial, over 20 minus, well, 18. There are 18 kids that are leaving in different orders, factorial. So that means it's 20 factorial over 2 factorial. Right? And so how do you punch this in the calculator? Okay, so this is what you do. You click 20, right? Punch that in. You go to math. Okay. You click the left button so that you're highlighted over probability, PRB at the very top. You go down to number 4, right? Should be an exclamation point somewhere in that list. Okay, great. And now you do divided by 2 factorial, which you do the same thing. Okay, do you really need the factorial though? If you're doing 2 times 1, right? You just write 2. That could be a thing you could do, but if you don't want to, just want to put factorial, totally fine. It looks small, but it's actually ginormous. 1.21645, and then blah, 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 e to the E18. What that really means is you're doing 1.216 blah, blah, blah times 10 to the 18th power, which will carry this decimal place over 18 times. That's what that's doing. You use this a lot in science class, especially chemistry. Sometimes, I didn't think that was going to do that. Use this a lot in chemistry, physics, typically, and they call it scientific notation. Okay, some of you have already been doing that, but others of you maybe haven't even started doing that. So good to know what that means, but you probably won't run into that, hopefully, again later this unit. Using permutations to find the probability. For a parade, you want to ride a float with your soccer team. There are 12 floats total in the parade. That's important. And their order is chosen at random. Find the probability that your float, so probability, your float is first and the float with the second course is second. So you're finding probability, not the amount of possible outcomes, right? So how many possible outcomes are there? Well, 12 factorial. How many is your favorable outcome? Well, you have 2 outcomes that you want to happen minus the 12 total, right? That's what that was at the top there, or at the other side. But notice we're kind of like flipping the problem around. So really it's 10 factorial here. So what that does is that you have 10 times 9 times 8 times 12 times 6, right? Really, you're doing this times 11 times 10, blah, 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 blah. So you're just canceling those out. And so really it's 1 divided by 12 times 11. This is what you're really doing in your calculator. You should have 1 over 32, or 132, which is, like a 0.7%. That's pretty small, right? Really change it to percents. 0.75, 75, yeah, all that. So pretty small chance that you're going to be first and they'll be second. Those are permutations. Combinations are an arrangement of objects in which order does not matter. Okay. Really, a lot of combinations are going to decrease the amount of possible outcomes compared to the permutation where order does matter. It seems kind of odd, but that's what's happening. So let's take a peek. Make a list to find the possible combinations of 2 letters chosen in A, B, C, D, E. A, B, C, D. So here's the deal. Combinations eliminate double counting. That's why that kind of plays an effect. So let's do the same thing we did before. A, B, A, C, A, D. That already came first. B, A, B, C, B, D. C, A, C, B, C, D. Last one, D, A, D, B, D, C. Now notice, we've already made some of these combinations before. We already did D and C together. D and C is right here. We already did D and B together. That's right here. We already did D and A together. That's right here. We already did C and B together. That's right here. We already did C and A together. That's right here. So finish circling the rest. Oh, wait, we already did this one. Yeah, don't count that. So look, 1, 2, 3, 4, 5, 6. We have 6 combinations. That's what you should say, 6 combinations. Oh my gosh, do we have to count? No, we don't. We have another formula. Sick. Same thing, but look, we have an extra r factorial at the end. That's really all combinations do. It'll not only subtract the those that count there, but it will make sure that it includes all your combinations with that last one, r factorial. Use the formula to find the combinations. You order a sandwich at a restaurant. You can use two side dishes. You can choose from two side dishes, a list of 8. How many combinations are possible? 8 different side dishes. You have 8 minus 2 factorial times 2 for the combination. Great. Looks like you're doing this in the calculator, right? Okay. Looks like you get 28 possible combos you could create. Ooh, this one's another probability one. Your book editor has 14 photos, including one of you and one of your friends, to use in a collage for a yearbook. The photo you replace at random. Photos are placed at random. There are 2 photos at the top of the page. What is the probability that your photo and your friend's photo are going to be the 2 placed at the top? Whew, let's see. So unlike the other probability one, we're not really going to flip anything around. We're going to look at their combinations here. We want to find the total combinations and then just put it over 1. That's what we're going to do. So what are our combinations? 14 total photos that are submitted. You have n minus 2, right? Because you have 1 in your friend. So 12. 14 minus 2 is 12. Then you have 2 factorial, right? Because you chose, that's the other r, right? You punch that in a calculator. Should get 91 combos, right? These are the total amount of combos of the 14 that could happen. You only want one of them to happen. So it'd be 1 over 91, right? Which is about, I don't know. Looks like it's a 1% chance. Pretty close. 1.1 maybe, right? But that's how you'd calculate the probability for that. Oh, yeah. So this is a good try on your own if you like. You just have to list the combinations or permutation and then find the answer. But I'm going to just throw the answers on here real quick. How many different ways can you arrange 3 letters in the word March? Well, that's a permutation because the order doesn't matter. So you have 5. Oh, I'm going to teach you a different way. In your calculator, if you did math and then you scrolled to the probability, you might have seen a little thing at the top that said NPR. So really, if you know your N and you know your R, you just have to type 5 and then go math PNR. Oh, NPR, sorry. Then you type, well, you want 3 different ways. This will get you the permutations. That's the fast way of doing it. I got 60. You can do the same thing with combinations. Count the possible combinations. Well, obviously then this is a combination. And it looks like it's the same numbers, right? A, B, C, D, E. So 5 letters. And CR, that is also in that math probability little application there. And you're choosing a list of 3. Cool. Okay, that looks like it should be less, right? Because you only have certain combinations you can create. Ten horses are running in a race. You have first, second, third. This is a permutation. The order matters here. You have people finishing first, second, and third. The order matters. So you have 10 horses total. They're racing. You want first, second, and third. So that's 3 desired, right? That you want to know about. There's 720 possible outcomes. Board directors of a company has 10 members total. How many different ways can you choose a committee of 3? Well, the order doesn't matter, right? They just have to choose 3 of the people. So combo. How many combos are there? So there's 10 people. It's a combination. And you're choosing 3. 120 combos. All right. Oh my gosh, we're so done. That's it. That's the last time you hear my voice, hopefully. But yeah, please feel free to come by and say hi next year. But other than that, this is Ms. Ferrick going out. Let me know if you have more questions and things of that nature. Good luck. Fun. And of course, I know you're going to do great.